Zoom in on that some still. I hate what it does when I zoom in. But so be it. All right. Well, I hope you guys enjoyed the homework we had this last time that I forgot to send out. So obviously there was none. We will have more after this class. I'll probably sort of combine what would have been the homework under the last one, but recognize that the homework is ramping up in terms of difficulty. So I probably wouldn't expect people to finish everything that will be in this one. It'll just be a large sample of problems. So from that, I'd actually just encourage you, when I do send it out, look at the different examples there, look at the different problems, and choose the ones that you think you can work first to try and build up your confidence, get some momentum going, that you don't necessarily have to work them in order or even do all of them, but it'll just be a good spread of different types of problems that we're going to encounter. Other than that, I think we'll start with review as usual, and then we're gonna dive into a lot more on objects today. We'll see how far we get. There's a lot of material I could go through. I want to keep it from introducing too much to you all at once. So we may stop before the material, everything that I have in here, just because there's so much to think about, and then come back to it the next class, because we're really going to start getting into more complex object structures. But the quick review, last time we talked about 3 new ways that we can pass parameters into methods. We talked about default values, symbol parameters, and splat parameters. Does anyone want to describe to me what default values are for parameters? Ariana? It's like, no! Yeah. Yeah, you've already set them. Do you remember how to set default parameters? All right, I don't know if I have a good, let me look here. This is more complex than what I probably want.
They're in the other person.
What's that? So let's just make something very simple. Very, very simple. Say x plus y, but let's give some default values to x and y in case somebody doesn't pass them in.
Actually, 0, y.
Yeah, it's just like you're assigning, except you're doing it inside of the method creation. That's the way that you would define some default values. Can everyone read this just fine? Yeah? Okay. Make it slightly larger too. Oh, that made this 2. Okay. Now, how about symbol parameters? Does anyone remember symbol parameters to our functions and how they work?
There's a colon, right?
Yeah. Yeah, put the colon. So the way we would do this with symbol parameters is x colon y colon. And why would you use symbol parameters when you're defining something? I'll just take this over here and we'll throw it into my workspace here. Get rid of that stuff. Don't want you to see that. Why might you use symbol parameters when you're writing a method? So let's define this first the way we had it before. Let's redefine this. We'll even give it the defaults. And we can call that, right, add. We can even pass in nothing. We could even give it 1 number. And if I had 1, I'd just get back 1. Or 2 numbers, right? Now let's go back to the definition that I did just a moment ago. Let's try those same things. Let's see how that works. What if we did add 1, 2? I didn't like that. Okay, does anyone remember how we call a method with symbol parameters? What? The key is you need to tell it what you're passing. You have to say this is for this symbol and that's for another symbol. So I'm telling it explicitly.
Oh, this is for X and this is for Y.
This is for X and this is for Y. Because it didn't work with just position, because each one of those symbols, it's expecting you to tell it the actual symbols instead.
I wonder if was the syntax for symbol hashes covered at some point?
Yeah, we talked about it a little bit.
Okay.
I'd have to go back and check the class, but we definitely did cover them some.
Gotcha.
Can anyone think of why we would want to use these again? Any thoughts?
In methods or in general?
Let's say in methods. Doesn't really matter.
To get some order in your parameters.
To get some order.
Yeah.
A good thought. One good reason, and it doesn't show up quite as obviously here, is now I could do something like this. If X and Y were different or had different effects, I can explicitly say I'm passing in Y. So let's say I had a method with 5 different parameters in it, right?
Mm-hmm.
And when I call it, I really don't care about 4 of them. They can be whatever the default values are. I only care about the 5th one. If everything was ordered and had to be only ordered parameters without symbol type names, then in order to call something like that, I'd have to pass in all of the ones, assuming it was the 5th item. But if you're using symbols, it doesn't matter the order. I can call this in whatever order I want, because it's mapping them to the symbols inside of the function itself. And I can pass in specific ones and let other ones use the defaults without having to do it in a given order or a given structure. So it gives you a lot of flexibility with methods when you're using symbol parameters to pass in different types of arguments, or different arguments, or not have to pass in a whole bunch of defaults or filler arguments when you have those types of situations. That makes sense?
Convenience.
Convenience, yeah. And then we also learned about one other type of parameter, the splat parameters. Anyone remember what splat parameters were? What's that? One with the star. All right. So you had like this. And what would happen with the starred parameter? Does anyone remember?
You put the you will put the numbers or the values into a string.
You'll put them into an array.
Sorry, yeah.
Yeah, into an array. So then now what it allows is a variable number of arguments. So you can pass in more or less arguments, and the splat will just capture whatever's left after a certain point. So if I'm going to end this and redefine it slightly differently. We'll say X, and then we'll do other numbers. Thank you. And then if we're actually trying to write something inside of this so that we add them up, let's say sum equals X is our starting point. And then numbers dot, how can I step through an array? Each. Add the number to my sum, end my block, and end my method. And now I can pass in, oh, look at what I forgot. Anybody see what I forgot? Got to actually return my value at the end. There we go. So now I should be able to call it with any number of numbers. And it'll go through them. Look at that, 42. What a coincidence.
Class is over, it's done.
So that's where splat parameters come in use, is when you might have a variable number of arguments that you want to pass into a function, and you don't know how many, you don't want it to be stuck with just one or two. You might use a splat parameter to accept a whole bunch of them. All right, classes review. We learned about classes last time. Does anyone remember how we create a class in Ruby? Process for creating a class. Class.new, close. That's how you create an instance or an object from a class. You create a class just using the class keyword. So class thing ends. So now we have a class there. Doesn't do much, but we created one. Now, how do I create an object from that class? We already had it. How do I create an object based off this class?
Thing one. Yeah, thing one.
Dot new. Yep. There we go. We can see that it has that as its class. Now, does anybody remember what method internal to the class or the instance method that gets called when you call new? What the name of it is? Initialize. Yep. It calls the initialize method when you create your class. Exactly. Okay, does anybody remember how we create an instance method? Let's open our class up again.
You define it within the class.
Define it within a class. That's a good way to state it. So within the class block, we'll define a method. Right? It's all flat normally. You're going to see some nice indentation there, but so now we can create thing one dot hello, and we'll get hi out. All right. Now, does anybody? Here's one that's now that one's a little easier. What about an instance variable? Instance variable in classes.
Class thing.
So let's open this guy back up. Let's do this hello again, but let's create an instance variable in here, and then we'll put the instance variable.
String word equals or word.
So you do word equals hello.
Oh. What's word?
All right. Well, let's do this real fast. It's gonna work,
Yeah.
but it's going to have deceived you. They were all of them deceived. So if I do thing one dot hello, it worked.
Doesn't the instance variable is defined outside of a method?
Not necessarily in Ruby, no. You can define instance variables pretty much anywhere in Ruby. It doesn't have to be outside of a method. But here's the key about an instance variable is once you have an instance variable, then every other method in that class, anything else in it, should be able to access it as well.
Right.
So I'm going to go back here. We'll reopen this guy. Let's do hello. Let's do it like we just did, where we said word equals hello. Puts word end. Now let's add another instance method. Let's say by. And so if we wanted to use that same word, what would we do in here?
Word equals by.
Oh,
You can't use the same name, right?
well, why not? If it's an instance method, we should be able to access it in here as well. We should be able to access it in anything. So we should be able to do something like this.
Right.
Getting down to the bottom of the screen there. And one dot hello. All right, that worked. But and one dot by. Undefined local. You notice there's a keyword there. This pointer doesn't work.
Done, huh?
This is a different one than over there.
Uh,
This one's all broken. I'll have to see it. I don't think I broke it. I think it was falling apart already. Because I just pushed the button and it just collapsed. All right, we're not going to be using that. So, you notice what it said there is undefined local variable.
Yeah.
Which means that the variable that we just created wasn't,
Accessible.
yeah, it's not an instance variable. It was local. It's looking for one local just to that that scope, which in this case is that method.
so what makes how do you define an instance method? I mean an instance variable. What would be the way to write it?
So we need to do something different to distinguish a local variable from an instance one that's going to exist on the object. And the way that we distinguish it is using the @ symbol first.
Oh, I see
Yeah,
what
yeah,
Oh, I
So we use @ in front of it to say this is an instance variable. This is on our instance. It's not local to this method. It'll exist for this object.
So couldn't you define that outside of that definition though? That definition of that method?
At Word, like outside of
Yeah.
the method, probably, right?
I don't know exactly. I'll try it in just a moment.
Yeah.
I'll try it in just a moment.
That's a good question. I actually am interested.
Like not outside the class.
Right, yeah,
Just
inside the
outside
class,
the method.
yeah.
Inside the class, not outside the method.
So now we have thing1 equals thing.new. We do thing1.hello. All right, we get hello out. And thing1.by, we also get hello. It worked successfully this time. And that was because we used the @ so it was on this instance. And it worked successfully. Now what you were asking was if I could do this. And I honestly don't know, so let's try it.
Yeah.
Where I can do class thing1 or thing, and then you want me to just do @ hello or @ word equals hello, and then let's say def hi, and we'll define this, puts word. That's what you're thinking of?
Yeah.
So let's give that a try.
Thing one.
Oh, thank you.
Huh.
Nope.
Yeah.
You can, if you're trying to define them that way, you create them in the initialize method, and then they'll be on your class at that point in time. And that's the way that you can do that. Does that make sense? Instance methods that exist on objects. We're going to circle back around to this stuff over and over again, so it's okay if it's a tiny bit fuzzy, but do you get the basic syntax of how it works, how to write them out? Yeah? All
I
right.
think like the instance variable is also unique to that one object, right?
It is, yes. That's an important thing. So if I did, well, I need to redefine my class here again. class thing. So let's do def I, because I'm lazy. At word equals hello. I think this is going to work the way I expect, so we'll see. What's the word in that? Now let's define by. What's the word end? So now let's create some objects off this, right? Thing dot new. Let's create thing two. Thing dot new. So thing one dot hi, I'm gonna get hello, but if I do thing two dot by, got nothing.
Makes sense.
Why is that?
Because you're defining your so thing one.
Now if I did thing one dot by, I got hello out.
Yeah, because you process thing one first, and you call the high method.
Mm-hmm.
So it's the instance variable word equals hello. So it already stores it and has actually content in it. And that's why whenever you call thing one dot by afterwards, you got hello. But with thing two, because you're actually creating a separate, unrelated object to thing one, you don't have anything.
Right, and I haven't called hi yet. And since I haven't called hi, I haven't yet created my word instance variable because that got created inside of that hi method. That's why when you were asking, can't you create them externally? You create most of the ones that you know you're going to want in your initialize so that they exist and they're there and ready for you to work with. Because otherwise you may have this sort of case where you try to output a variable and it doesn't exist.
That is actually can be achieved with double as I just discovered.
With at the top level.
Mm-hmm.
I figured there was a shorthand. I don't know how. I didn't know off the top of my head. So thanks for looking it up.
Class variable.
What?
The class variable, right?
Is it a class variable
Yeah.
in that case? Then it will work differently.
Okay.
So yeah, a class variable would behave differently.
Okay.
Because it would be attached to your class. So then if you change it, it should change for everything.
Okay.
So you know how in C++ and Java you have a different like security accessors like private.
You have private, protected, and public. Yeah.
Do you have any of the sort in Ruby?
Yes.
You do? Yeah. So like you can make an instant variable private.
Yeah.
Or
An instance variable is private.
Yeah.
Right.
We'll get to that in just a minute. We'll talk more about those later. We're not going to get into the different access levels today, but we will talk about that. But an instance variable is private, and we'll get into that today. Because that's how they work a little bit differently than other languages,
Okay.
depending on the language. All right, people feel relatively comfortable with instance variables now? Okay, so we're gonna get into more on objects. This immediately the next topic is right what he was asking about. So we know how to create instance variables using the @ symbol, but how can you read or change those values outside instance methods? So we know how to change them inside of it. We just did a hi or hello, right? We set it, we could change it. But let's say I wanna change it somewhere else. I want to change it. I want my code here to be able to say thing one dot word equals hello. And it just told me undefined method word equals for thing. All right, it didn't like that. So let me just, can I get the word? Thing one dot word, undefined method word. So I can't even read this. Maybe if I do a thing one dot at word. Now that's a syntax error.
You're trying to access the actual instance variable.
Thing one, let's make sure that thing one still exists. It does.
You can tell me that they're private.
Yeah. that
So-
you can't. So here's going back to our old joke that we had. We'll build on this more and more today because why not? Oh, of course it blew up. I copied everything. So we brought the joke in, and if I've created a joke and I try and access programmer joke dot question, it's not going to work. Or programmer joke dot okay at question maybe. No.
You're gonna have a method. that-
So I don't have access. Yes, I don't have access to any instance variables directly. So what you need to use are what are known as getters and setters. Getters and setters are very, very simple. Here's our joke. We can add in getters and setters. Define a method. Name it the same as your instance variable. It'll take an argument and then it'll set the value to that. And then define one, name it the same, and it doesn't take anything, and it'll just return your instance variable. And you can do that for both of them. So this is how you can define getters and setters in Ruby. So that now, if we create a joke, we can do joke.question and get just the question out. But it's not, the key here is it's not giving me this method directly or this instance variable directly. It's calling a question method that has no arguments, and that question method is just returning the instance variable. Does that make sense? So you don't have any direct access to these instance variables from outside, but you can create these getters and setters if you want to change them. So let's go ahead and change it now. Let's make it a different joke. Joke dot answer. So I'll do the question first. Question. When does a joke become a dad joke? Oh, it's upset with me. I must have screwed something up. Given 1, expected 0. Give me a moment. Oh, hold on. Should work, right? I don't what? Maybe it didn't. Yeah, I don't think that was gonna work. So maybe I didn't create it correctly.
You have symbols,
Question, takes an argument.
like, it takes the question and the answer right away, right?
Should work.
Yeah. All right. Here's what I'm gonna do.
You see, look,
Just do just a regular dot question, see if it.
Like this.
Yeah, see what it, okay. So you have the setter. It should work.
It's not happy with that. I may have had a typo or something else. I don't know.
is that considered the getter and the setter,
Yeah.
both?
What? No.
No?
You should need to define separate ones.
See if you can pass an answer, if answer is broken too.
Yeah.
Interesting.
Yeah. I can get it out. Maybe I did something wrong here and I'm not allowed to redefine it or overload it, but I was pretty sure I could do this.
Scroll down.
Or this isn't right. I just didn't change that, but. All right, I'm gonna do something here. I'll double check what's wrong with that later. And I will get back to you. So I don't know. It might be because of the names of the parameters that I used. So I'm gonna try this. All right. It's just taking whatever's the last defined one. So I think I defined my, I think I needed to define my getters differently. I think the key to it was to define them like this. Let me fix it for the setters. So I think this will work. We'll see. I'm gonna try something out of the blue here. Last joke. So let's define this again. Question at question end, and then I'm gonna def question equals.
Oh, I see.
And I'm gonna joke dot question equals. All right, and that worked. And the reason that worked is because I defined a different method. So I wasn't allowed to use the same method name and overload it. So instead, this is an actual method with question equals as my method. You might be interested in, wait a minute, didn't you put a space there in between stuff? Ruby really doesn't care about that. It's gonna pull that stuff out when it parses it. So it's able to handle it, me writing it in this setter type syntax, even though I defined it just question equals directly. And then I better open it back up and fix my answer as well. That one should still be good because it doesn't change it. So joke.tell joke. It says, how can you tell when a joke becomes a dad joke? When it becomes apparent. Right? Oh, yeah. Yeah. Don't worry, we're getting there. I'm going to help you out. Okay, so I'll need to fix that. I have it just slightly wrong here in terms of the way you would write that out. But that's how you write getters and setters. And that's how you're going to access instance variables. You're going to do it with instance methods that give you access to them. Otherwise, they're not exposed. Unlike some languages, C++, I think Java, it's been a while since I've written it, you can just define the variables as public directly and then access them externally. Although Java has moved much more towards a getter setter model, a lot of people won't do that.
C++ does this as well.
Yeah,
Yeah.
they've moved towards a getter and setter model. When I wrote it, they didn't have them directly. You could define stuff around it, and we did a lot of that.
When
But
they teach you classes, they teach you set it private and then to get it.
yes,
To put a getter and a setter.
yeah, but in those you have to explicitly create them privately. Whereas in Ruby, they are just private, and you have to explicitly set getters and setters, or you're not going to have access to it externally. So you saw me doing some crazy stuff there that somebody should have blinked at for a moment if you were paying attention at all to what was going on while I was trying to fix the joke. Did anybody notice me doing some really weird stuff that threw you for a second? So if you were watching, I did class joke, went in there and changed some methods, ended it, but did I create a new joke object at all in between them when I was doing that? I didn't, did I? I just kept using the same joke object. Okay, is there anything strange about that? I added new methods to my joke class. I added the setters that I had wrong, and then I called them on my existing joke object that I had created, and they worked. This is what's known as monkey patching in the Ruby world. This is something that does not exist in a lot of very classic object-oriented languages. It's a very powerful feature. It's the capability to basically open back up a class that has already been defined and you're working with and add behavior to it. And that behavior will get added because remember, we talked about instance methods. While they talk to each instance, they're attached to the class and there's only one of them. They just get the data from the instance when they're called, right? So if we redefine or add new instance methods to our class, those can be available on objects that we've already created from that class. So we're going to do that here. We're going to add a new method to our joke class. We're going to groan. Bad joke. Boo. Right? And end. What we've done here is, it looks like I just created a class, but since a class of joke already existed, I instead modified that class and added new instance methods to it, in this case, a grown instance method, that's now going to be available on every object that has been created using that class. So now, on this joke that I'd already created, I have the grown method that's suddenly available. If I create a new joke,
That's blowing my mind right now.
what?
That's blowing my mind a little bit.
Yeah, it's not something that exists in other languages. It's not something that's probably used a lot, but it's a pretty crazy capability of, this is a feature of a dynamic language where it hasn't compiled down to machine code at some level. So with Ruby being dynamic and reinterpreting the code continually, you can change it on the fly much more easily. Some of this capability does exist in other languages. In, say, Java or low-level languages, they will call something like it reflection, but it's much harder to accomplish these same things. Then again, you also get a lot more type safety and security when you can't just go in and add methods to objects that already exist. We'll see just how dangerous that can be in just a moment. So if we create a new joke, right, we'll see this joke. This is our old one, our default. But it also has grown because we're creating it from our joke class. So this is known as monkey patching, or there's other terminologies for it. I'm introducing it now just because I'm lazy and I don't want to type out my whole class every time I'm adding something new to them in class. So I wanted you guys to know what's going on when I do this so that we can make small changes to our classes going forward and show what's happening. You can also do this not just to classes that you've created. So we can, let's do this string one. String is a class that already exists, right? We've seen a lot of strings. So let's add something to it. right? And now let's create a string. Right? I have a string, but this string has a new method that didn't exist before. And if we did string.instance methods, it's going to be in here somewhere.
The second one.
Is it? There we go. My monkey patch. Or if we did poem.methods, we're going to see it right up there, my monkey patch. So we added something to it that wasn't on this object before, and it got added in. You can also go into it and change existing methods. You saw me doing that before, again, with the setters and getters. I screwed them up a little bit, so I went back in and redefined them. So I'm going to have to get out of here after I do this because I'm going to break stuff. Let's change something. What's a method that we know about on string already? One that we've used. Downcase? All right, let's do downcase. And what do we want it to do instead? Upcase. Ooh, we're going to do that in a moment. Let's come back to that. Let's come back to that. Because there's a challenge with that, and that's great. That's going to lead right into where we're going. I love it. Let's do something simple. Let's just do something else.
Some men like to watch the world burn.
Some people like to watch the world burn. Okay. Sounds good. So now poem.downcase. Ah! I've broken my string class. Anything that I have that's a string now is not going to have access to this downcase method anymore. Boom! Oh, what a shame. This is awful. So this is why monkey patching is something that's really cool and something that's also incredibly dangerous. Ruby, it's a little safer. Some people did monkey patching on JavaScript when they really wanted some functionality that didn't exist yet. And it has become a huge faux pas in the JavaScript community because you don't control the browser where your JavaScript runs. And so you may break somebody else's code when you monkey patch JavaScript as a language. Ruby's a little safer because you're usually not running somebody else's random code on the same site. But it's still a dangerous thing. You need to be aware of what can happen when you're doing that. What's that? It's gone. I don't have access to that method anymore. What? I don't know. I honestly don't know. I think it's gone. There may be a way to get to it, but I don't think so. Yeah, it's a great question, though. All right.
You probably would have to just rewrite it again in the way that Ruby has
Yeah.
written it. Yeah.
Just rewrite it in the way Ruby's written it.
Yeah.
So what did you say you wanted us to do? You wanted us to have downcase do upcase, right?
Yeah.
All right. Let's try and do this.
It translated into like Italian. That'd be awesome.
So we know up. What is it? Is it uppercase? Is that or is it upcase?
Upcase, I believe. Yeah.
Upcase.
Yeah.
All right. So how are we going to do this?
Find out case. Okay.
What's that? Upcase. Okay, but that's a upcase. All right.
Mm.
You have to have like an object to call it update on.
Ah. Uh-oh. How are we going to do this?
Oh, you get a setter, right?
How are we going to do this? All right. Let's talk about self. Perfect. So what if we want to do something with the instance? Like such as repeating a joke in a different joke method, or take a string, reverse its order and make it all uppercase, or make it uppercase, right? Instead of downcase. How are we going to do that? The way you can refer to the object that you're in when you're in an instance method is using self. So you say self to get a reference back to your own object. That's how you can access methods that exist on your object, because otherwise, if we did just upcase, it's going to be looking for a local variable inside of here, and there's not an upcase local variable, so it's either going to error out or we're going to assign a local variable. You can do self.upcase, and that self is the key part there. Self lets you refer to yourself inside of any of your methods. So that's how you're going to be able to get access to any other methods or any setters or getters. In fact, frequent practice in a lot of languages is using internally. You're not necessarily referring to the instance variable. You'll use setters and getters as much as possible. So now we have poem.downcase. And it goes to uppercase. All right. Or we can open our joke back up, which is going to be my other example. And let's redefine our grown. Let me see what I had here. All right. It's a bad joke. Never tell it again. And then let's be really cruel. And let's go self.telljoke. Why? Why would you do that to me? Right? So now we can do grown. Let's tell the joke. And then joke.grown. And we can reference ourselves inside of our own methods. And this is going to be something you will do a lot when you're trying to work in your objects is, oh, I need access to another method on this. So self is the syntax for that. That's how you get access to them. Does that make sense? We're pretty good on that? Okay. So now let's step away from the concrete Ruby examples for a moment. And let's talk abstraction. Let's talk objects and classes again at sort of a higher level. We'll do some whiteboard work here to go through some things, and then we'll bring that back into Ruby. So this is more fun and interactive. We've created a bunch of different jokes or different objects of types, but as you write more classes, more objects, you start doing this, you're going to begin to see that a lot of methods, a lot of properties, they're going to be common between your objects. And that'll be something that'll pop up really quickly. And one thing that will get annoying with that is if you're writing every class from scratch, then you're going to be doing a whole bunch of duplication in multiple classes. So let's say, what are some different types of jokes we could tell?
Dirty jokes.
What?
That joke.
A dirty joke?
Yeah.
All right. A dad joke?
Fart joke.
A fart joke?
PG joke.
About you do a knock knock joke?
Knock knock joke. Little Johnny jokes.
I think that goes in this category.
Yo mama jokes.
Yo mama, right?
Racist joke.
So, yeah. So we've got a whole bunch of different types of jokes. What are some things that are common between these different types of jokes?
It's got a script, or it's got a question, and it's got a.
A lot of them are going to have a question, right? Do you want to write here? I'm only asking because I'm left. I guess I can do it. So I'm going to block it. Yeah. We can do a questions or a common characteristic. What are some other things that are common between them? Answer, right?
Punchline?
Yeah, like a punchline, sure.
Reaction.
A reaction, yeah.
That's pretty basic.
So I think that's good. And if we wanted to create specific classes for each one of these types of jokes, then we could create them from scratch where we could have, oh, well, some of them are going to be question and answer. So let's, on those ones, like maybe the dad jokes and things like that, maybe dirty jokes or fart jokes. All right, well, we're going to have those as question and answer. And each one of these classes that we create is going to have a question, an answer, and a tell joke, and a way to do that. And then some of them may be a little different, right? The knock knock joke is a little more. It's got 2 questions and 2 answers, more or less. And the yo mama joke is really just a punchline. You know, there's not a question or answer on that. It's just straight to the punch. So there's also differences between them. But if we're trying to write them out, you're going to begin to see those patterns. And you're like me. Again, what's one of the lessons I taught you? A good programmer is a lazy programmer. You're going to get annoyed at typing this out over and over again in all of your classes. So what we're going to learn about, and I'm going to use another example that's probably more common and going to give us more tools in just a moment. What we're going to learn about is how objects and classes in particular, can depend on characteristics from other classes so that they can share behavior, and you don't have to redefine all of that behavior each and every time that you're creating a class. And that's a very, very powerful aspect of object-oriented programming, is being able to leverage that. So now let's go with a more canonical example. Again, we'll keep whiteboarding for a while. We'll do this one, which is you're going to see all the time. Let's talk vehicles.
Oh yeah.
All right. Sure, you can do it. So let's talk vehicles. What are some different types of vehicles? Subaru. Yeah.
Sports car. Racing car. Pickup truck. SUV.
Sounds good. You have a motorcycle, right? A bicycle. Perfect. So we've got a nice solid list of different types of vehicles here, right? What are some traits that all of these vehicles share? They've got wheels.
They have a chassis. They have an engine. They have headlights, rear lights.
They have a chassis. Do they all have an engine?
Oh no, they don't.
Oh, a bicycle may not have an engine, but it's still a good one to list. Yeah. Oil.
Tires.
Tires, yeah. It goes well with wheels, but they're definitely different. Tires and wheels are different. So, and then let's say,
The color.
yeah, they have color.
There's so much.
What? There's so much. There's a lot,
A lot
right?
of stuff, yeah.
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 So when you're looking at these traits, we can begin to break some of these down. And this is a great list because it helps us do this. So if we're looking at wheels and tires, out of the objects that we have here, which objects share those characteristics, those traits? All of them? Yeah, all of them. All of them have wheels and tires. All right. Now, what about a chassis? Everything has some form of chassis. And color? Everything's going to have some form of color. What about an engine? No, only the cars or the motorcycle.
The motor vehicle.
All right. And some, yeah. Now, what about the number of wheels? Yeah. Right? So what you see here are the differences and the similarities between these different types of objects. Now, if we're writing these out in code, nobody wants to write out wheels and tires and chassis and color for every single one of these that they're going to create. So if they're creating classes for sedans and coupes and sports cars and racing cars and motorcycles and bicycles, you don't want to recreate those characteristics on all of them. You want to share as much of that as possible in your code so that you don't have to duplicate your code, so you can be lazy, so that if something changes, you can share that behavior. If you had a bug, you don't have to fix it in 1, 2, 3, 4, 5, 6, 7 places. You can fix it hopefully in one place or just a few places. But there's also things that are different between them that aren't going to be the same on every object, and you're going to want to have different. And some of those are still shared between different classes or different categories of objects. The wheels, well, that's shared. Bicycles and motorcycles share the same number of wheels, and the rest of the vehicles share the same number. Chassis, though, well, everything has a chassis, but chassis type is going to be different for every vehicle, unless, you know, you're Subaru and you build a few different cars with the same chassis and just put something different on top of them. They actually do that. Ford does it sometimes too. Color, that's going to be something that's unique to every object that you create, most likely. You're not going to have the same color on every vehicle, especially if you're, say, a Mini Cooper. Every one of them is going to be unique. So some of these are characteristics that make a lot of sense to customize on each object, but not all of them are we going to want to customize on each object. Some of them we're going to want to have a shared behavior between things. And the way that we handle that when we're doing programming in an object-oriented model is through what's known as inheritance. I'm going to look at the time here. I'm only going to just start touching on inheritance so that we can introduce it. I'm probably going to finish sort of in the middle of this versus getting all the way through it, but I want you guys to have gotten more familiar with this concept. So we've already learned that everything has a class in Ruby, right? Everything has a class. Let's make this bigger. Let's go with something very basic. 42.class. We've got a class. But there's also a concept that classes can inherit from other classes. This is the inheritance chain, and these are going to be called superclasses. A superclass is the class that you inherit from, and the class that inherits is called a subclass. So let's try this out. Okay, we have a class here. We also have a superclass. So our fixnum superclass is integer. Okay. Well, now I'm a curious person. I want to see how far down the rabbit hole this goes. How far does this go? Does everything have a superclass? Okay. So an integer superclass is a numeric. All right, that's interesting. Well, let's just keep going down the rabbit hole. Superclass. Object. All right, what about this? Basic object. Oh my gosh. Do we go farther? Nope, nothing. So basic object, there you go. Basic object is the root of this. Now let's try something else. Let's try our poem. We know its class is a string. How are we going to find out what its superclass is? Superclass, Superfly. All right, we go down to an object. We already know what an object superclass is. What's an object superclass? Basic object. So your superclass isn't going to change just because that happened to be a string. Once we got to the superclass of an object, its superclass was still a basic object. That's going to stay the same in that respect. Let's keep going. Let's try something slightly different. 42.0. What do we have here? Anyone remember? What? That one's a float. All right. Now how about, you guess? Numeric. Perfect. And then we already know that. What was that? object and basic object, right? Now let's look at ours. What did we create here? We created a joke, right? Joke.class. Joke. So superclass. Object. String. It's an object. By default, unless you do something other than the standard, your superclass, if you create a new class, is going to be an object. Does this make sense so far? We're going to talk, we'll talk a lot more about inheritance and how this works in the next class, but this is a table of the basic objects that you're going to encounter and their inheritance chain. You can see everything works down to a basic object, but we also have an object, but then you have numeric, float, integer, fixed num, and then all of these are straight off of object. Your string, array, true class, false class, nil class. Let's look at that one real fast. So if we did nil.class, got superclass, right? Superclass, and then I'm doing this because, wait a minute, I got back nil, what? Yeah.
That's really weird.
It's magic land. Nil has to have some exceptions to the rules in weird ways, right?
And like if you add it again, then it will say no superclass method on nil.
Yeah,
Yeah.
it's gonna blow up
Yeah.
because you got back a nil object, and the nil objects are special in a little bit of a
So is there,
magic way.
you see how it goes basic object and then object, is there anything else under basic object?
Is there anything else under basic object? No.
So that's it, basic object, object.
Yes. Yeah.
What about, is basic object the most superclass there is then?
I believe so. I think everything's going to inherit from object and basic object. I don't know if there's anything else. I could check, but I don't know if there's anything in Ruby that doesn't inherit from both of those. There may be a reason to inherit just from basic object.
Yeah.
But I'm not certain. Okay, so we've talked a little bit about inheritance. Now, we said, hey, there's value in being able to share stuff. How does that work? What's going on here? Well, I'll show you how to inherit a little more in the next class, but we can start looking at what this means a little bit if we go back into our code and look at some of this stuff. We've looked at the methods that are available on an object before, right? And we've even done that with classes, except you use a different method for that. You remember what that method is? You're looking for it on a class. Instance methods, right? Okay, so if we're writing some code, we get the class of this, and then we want the superclass. How are we going to check what methods would be available on this? Methods. Try that. It worked, but you might notice these aren't really mapping for the most part down to this same set. They're different. There's some that are common, but so let's try this. If we do the instance methods, because what we got back was a class, not an object off of it, then we can see the instance methods that exist on this superclass, and that superclass of fixed num was what again? People remember?
The superclass of what?
The superclass of fixed num? Integer, right? So we can get back the instance methods on that. Well, let's keep going down this chain, right? People remember what the superclass of integer was? Numeric? Yep. Let's look at the instance methods there. All right, it looks like a lot of these methods are defined down here. That's very interesting. Go down another level. What about numeric? People remember what the superclass of that was? instance methods. Oh, that's interesting. That list looks a little smaller. All right, I think we can go one more time, right? That should get us down to a basic object. Let's look at what we have on that. Oh, not much at all on the basic object. It looks like it has not, an equals, and not equals, this send, an equal question mark, so that should return some sort of Boolean. Instance eval, instance exec, and ID. Very, very little is defined down on the basic object. So if we go back up and look though at our top level one again, what you will see is we have this ID. Oh look, there it is. That ID method came from our basic object. And this instance exec, oh, that came from our basic object. Instance eval, look at that. Equal, send, not equal, not. Well, there's something a little funny here though. Do you notice anything funny? Because we went back through the ID, instance exec, instance eval, equal question mark, send, okay. Not equal, whoa, where's equal equal? It's up here?
Yeah.
All right. Any guess as to why that didn't show up at the same point in that list?
It's probably overloaded there. Or overridden.
Yeah, we'll get to that later, but what this is showing us are these were the methods that happen to come from the basic object, and it's using the basic object's definition of those methods at this point in time. It is possible for a class to change the definition of a method. Talk a lot more about that in the next class. You can also, and this is another way to do this, it's really sort of nifty. So if we want to see them instead of walking them down that way, we can do something like 3.methods minus object.methods. And then we're going to get a list back out of the methods that this has that aren't defined on the object. Now, this isn't perfect the same way as looking at the instance methods the other way was, because I think let's see here. I think I can do it this way. This will make more sense. If I do 3.methods minus basic object.methods, got most stuff, but you notice what is missing from this list that we were just talking about? Equals equals, right? And that's just because it's actually just doing some array subtraction. It's taking all the elements out of the array that weren't in the other array, or that were in the other array. And so even though that equals equals, it's not actually using the basic objects version of it. It's just subtracting out of the array. So this isn't a perfect way to look at the items, but it's a very good shorthand. So we could also do this, 3.methods minus fixnum.methods. What do we think we're going to get out of dot instance methods? Oh, yeah, this isn't working right. Anyways, hold on. Basic object. Dot. I need to look at the instance methods for these. There we go. That's why our list was shorter. So I should be looking at the instance methods on the classes. But you still see it was doing the same behavior. All right, so 3.methods minus fixnum.instance methods. Any guesses? What are we going to get back for our array of methods? So what type of object is 3? It's a fixnum, all right?
So you're gonna get everything but its methods, its instance methods.
Everything but its instance methods? You go back nothing. Nothing because
everything gets inherited. Okay, I see.
Because because the fixnum has all of the methods of everything in its chain, and since we haven't added anything to 3 since 3 is a fixed num, it subtracted everything, right? Now, if instead we wanted to look at what do we have that's not a, what was it? Integer? Then you can see the much smaller list. And you can sort of work your way back.
You can do the equals too, right? On the 3 methods and fixed num instance methods.
I mean like this?
Yeah. At the point.
Yeah, okay. That's good. I see what you're saying. Yeah, so those are the same, right?
Yeah.
It just compared the arrays and they're the same.
Yeah.
Is that making sense so far? In terms of how this inheritance works and that methods can be defined on higher level classes? We're gonna, again, we'll come back, we'll talk about this a lot more. I want to start introducing the concept, introducing the idea of inheritance, that methods can be defined on a class and then another class can inherit from that class and get the behavior without having to rewrite all of that code. So if we go back to our vehicles, we've got some things that make a lot of sense to have in a lower level base class if we're trying to do this. And we even might be able to come up with some good base classes. You guys haven't even gotten into writing this yet, but what might be some better base classes for some of these vehicles if we're trying to create something that can be shared?
Movement.
What?
Movement.
Movement? What we're trying to do is not necessarily describe the methods. I'm looking for the base. Like if we took some of these and said, oh, these are similar in this way, can I describe a class that might help? A more generic class that might group some of these logically. What? Vehicles. All right, perfect. Let's start with the vehicle class. That seems about as generic as we can be, right? That's going to have some very low-level properties and methods attached to it. Now, let's say we want to have something a little more specific.
Motor.
A motor vehicle. I like it. All right.
Electrical.
So an electrical vehicle, would you put that under a motor vehicle, under a vehicle?
Yeah, you're right. Never mind.
I mean, it could go under either, I'm just saying.
Engine.
What? An engine? Well, that would be a property that probably is a property of a motor vehicle.
So the other one would be manual vehicle.
And then, sure, I think that's good. Manual. What?
It's a green vehicle.
It's a green vehicle, right?
Yeah.
And then you may even have subclasses under a motor vehicle, like maybe a car. Car might be a good one because cars are probably going to share some properties. And so if we start breaking stuff out, like we did here, oh, we have an engine, right? Probably fits in motor vehicle. That's the most logical place because everything under there should share an engine. So the concept of that property should exist here. It may change and in some of the subclasses, but it should probably exist in this superclass. What about wheels? That should be, it'll change,
Yeah,
but
so that should be in vehicle.
should probably be somewhere up here, right? Wheels.
And tires as well.
Tires, right? What about oil?
I mean, you use oil in almost any vehicle. It's not engine oil. You know.
It's an interesting argument. You're gonna use it on a bicycle in some way. You're gonna oil your bike chain. I like it. I like it.
I'm gonna change the oil on my bike.
Yeah. sometimes you clean your bike chain and you gotta re-oil it. Right? What's that?
Yeah.
Yes? What?
The oil.
One last thing.
Where would you put oil?
The oil you had to take it to get it for your car.
A car? Sure, oil could be a property of a car.
Can also be motor vehicle.
Could also be a motor vehicle.
It can also go under vehicle.
But it might be, as you mentioned, maybe a subcategory of motor vehicle is electric.
Yeah.
And so maybe oil needs to be in another subclass. I don't know. There's no hard and fast rule when you're creating classes in terms of where something goes, what the hierarchy is, and how to fit them together. It's an art. It's something that there's a whole bunch of debate in. We'll talk about two different approaches to dealing with these behaviors in class over the next 2 weeks, because the two main approaches, the one that we've been talking about right now is inheritance. That's the standard thing that you're going to hear a lot about in object-oriented programming is you're inheriting. A motor vehicle inherits from a vehicle and inherits behaviors and traits from a vehicle. The other approach, and I didn't have it on here, that is pretty popular, but you usually don't hear about it until later, is what's known as composition. And that's where you're composing similar properties together as opposed to always inheriting. Because sometimes it makes sense to compose an object of other parts. And when you're building stuff, it will be a combination of both as you get into larger and larger object-oriented programming. Some stuff will be inheritance, some stuff will be composition, taking different parts and putting them together.
And,
We talk, yeah?
Sorry. I think like to the oil point, and you can correct me if I'm wrong, but like you're gonna hear a lot about, I guess in programming, about abstractions, right? So that would be like talking about what is the correct abstraction for something after much discussion. So the oil, like all of us had a different opinion on what the oil is supposed to be. And I think that's the art component, is being able to name something that you decide as a group as to what it actually is. And I think that's the concept of abstraction, right?
Yeah, the concept is where can I put these properties so that it's at a level where I want to work with them, but not at a level where I have to deal with it necessarily all the time in complexity. So if something's moved all the way up to, if I put everything in a vehicle, then this vehicle object is going to be incredibly large and complex. And it's not going to be easy for me to work with. And if I subclass out of it, well, they're going to have to deal with a lot of behavior that they take out of this vehicle property. Whereas if I make this small, and then I put something more complex in the motor vehicle, then I can abstract certain things in this vehicle and put other stuff down here where I care about that detail, and this deals with these different properties. So you'll hear, yeah, it's a great point. That's abstraction and putting stuff in the right place so that you're thinking about the right abstraction at any point in time is important. And being able to move up and down the layers so that sometimes you're thinking of, this is the exact code I'm writing inside of a function or a method, right? I need to think of exactly how to write that code. And then a lot of other times, you don't care what's inside of a method, you just want to call it. We do that all the time already, right? We do poem.reverse. I don't care what's inside of reverse when I use it. And so reverse is an abstraction for me. It lets me forget about how that's written and deal with just what I want to deal with at the top level. This is just another way. Objects are just another way to do all this abstraction. They're just a much higher level than methods are directly. Does that make sense? All right. Let me see if I had anything else I want to talk about. We've already talked about writing our own class methods because we've been doing that. We're going to have some assignments on that as well. That's just def inside of your class. So I think that's pretty much what I wanted to cover tonight. Any questions on anything for tonight? All right, I'm gonna stop my recording here.